At t equals 0, a stone is released from a hill with a vertical slope of height 100 meters. At same instance, another stone is thrown upward from the bottom of the hill with a velocity of 50 meters per second. Now this one thrown up. Now this one, initial velocity is 0, right? Released. Initial velocity is 0. It moves down, right? Then I will take this one as A, this one as B. Then the time when they meet each other, gravitational acceleration is 10, right? For this motion, I am consider relative to A. Relative to A. First, I'm going to find it out the relative velocity, right? Then objects are moving opposite to each other. Then relative velocity V, B to A, if you want to take that, you have to add, because opposite direction we add. Then 50 meters per second. Then for this one and for this one, gravitational acceleration is occurred for both, right? Then no any relative acceleration. Both accelerations are same. Both velocities are same direction, same magnitude. Relative velocity is 0. Like that, acceleration also, if it is equal, both are equal, then it is 0. Then I can apply for upward relative motion relative to A, S equal ut plus half at square. Actually this A now 0 for relative acceleration. This one 0. Then this term is 0. Relative distance between them 100 meters. Relative velocity we found out 50. What is the time? Right? 50 times 2 is the 100. Then t is 2 seconds. Right? You can take this answer by considering the relative motion. Let's go deeper into this. What do you mean by gravitational acceleration 10? That's mean if you projected something vertically upward, acceleration means velocity change for 1 second. Then 1 second, 10 meters per second, it change. How? If we projecting upward, velocity decreases. It's moving downward, velocity increases. That's the only thing you want to know, right? Now, here, initially, 50 meters per second. Then, next second, it will be 40. Next second, velocity is 30. Next second, velocity is 20. Like that, velocity decreases in this object, right? It's projected upward. Now this one, start with 0. Next second, velocity should be increased. Here 10. Next second, here 20. Next second, 30. Like that, its velocity is increased. Can you see here 0 and 50? Moving opposite direction. To get the relative velocity, we have to add 50. Can you see 40 and 10? Add 50. Can you see 30 and 20? Add 50. Can you see 20 and 30? Add 50. Can you see the relative velocity is always constant? That's why we consider acceleration, relative acceleration is 0. Right? The other thing, when it's moving to here 1 second, moving to here 1 second. Now, this is the initial velocity, this is the final velocity. Then, what is the average velocity between this 1 second? Average velocity, you can consider here 45 meters per second. Why? Initial velocity final velocity, you add those two and divide by 2. Then this one means for 1 second, it traveled 45 meters. Right, here, initial velocity 0, final velocity 10. 0 and 10, average velocity is 5 meters per second. That means 1 second, 5 meters it traveled. Then first second, this one traveled 45, this one traveled 5 meters during first 1 second. Next second, 40 and 30, average velocity 35 meters per second. 1 second, 35 meters. This one, 35 meters. This one, 10 and 20, average velocity 15 meters per second. 1 second, this one travels 15 meters. Then 45 and 35, this one traveled 80 meters during first 2 seconds. This one, 5 and 15, 20 meters during first 2 seconds. 20 and 80, this one traveled 20, this one traveled 80. Totally, these two traveled 100 meters. Then the collision occurred here. Then for that, here 1, here 1, 2 seconds motion for this one, 2 second motion, collision occurred at 2 seconds. You have to analyze like that to get the answer as a review, right? This is the answer and this is the review for this question.